All right, going to have a quick review here and then also a few slides. I'm going to go through these a little bit more quickly. It will keep the lecture length down. And normally we would have some discussion, which we won't be able to have. I appreciate everyone's patience for this incident, which obviously was not planned, but hopefully you guys will still be able to get this material under your belt. And you can also refer to the text. A lot of this stuff is mentioned in the text. Just a reminder, there's a remote homework assignment on Blackboard, Module 6. It's your last homework assignment. It is due October 17th. That is a week later than what was originally scheduled. And now you get to have a little more time to do it. I am still missing topics from several class members. If you have not submitted your topic, you need to start that conversation with me. It usually takes a back and forth a little bit as we clarify it. So please get going on that. This is 30% of your final grade, and it will actually be difficult to get to pass if you don't have your paper in. And before you can do your paper, you have to have an approved topic. After this module, we're going to discuss AI, machine learning, cybercrime, and future challenges. The third exam was already on, this is supposed to be the 26th, Thursday, October 26th. That is the last day before Halloween. The paper is due on the 29th, which I believe is a Sunday night, and presentations will be delivered on the 31st, and so on and so forth. I will randomly be determining presentation delivery, and also everyone who has already given their presentation will still be required to attend. People who give their presentation and then skip later sessions will lose significant points on their paper. It's just a matter of fairness and politeness and giving your students the respect to let them have an audience as well that you got to have. This is a video that I'm going to ask you to look at. It will take, I think, 10 to 12 minutes. Just pull the URL there, go watch it on your own time. There are a number of challenges introduced by software, and many systems, one of the things we have is called model-based testing. It's where you have a software package that can model something, like model the way an airplane flies, or allow you to model new wings, or model new bridge struts, things like that. And so a lot of things are quite efficiently built first by modeling them and testing how they will behave in various conditions using software. The advantages of this approach is very clear. It's a lot cheaper. It can be a lot quicker than actually building something and then running it through tests and building it again. To be able to do something in software gives tremendous advantage. The problem is, and it's an obvious problem, what if your model is terrible? What if your model is not effective, or your model doesn't handle some edge condition very well? Then you will actually have you'll build something based on what the model tells you, and it won't work. It's still used because it can bring tremendous efficiency to those who use it, but those who use it have to know the limits. They have to know where they can use it, under what conditions they can use it, what it models well, and what it models poorly. There are a number of pieces of software that model data packets in a data network, and those do not actually model it all that well. There's a tremendous amount of work out there over the last 25 years. People try to model the behavior of data packets, when they arrive, how often they arrive, do they arrive, you know, truly randomly. It turns out they really don't. They arrive kind of like trains, big clumps. But how do you model that? How big do you know it is? And so one of the things that people who want to build networks want to do is they want to model how well their device is going to handle certain kinds of conditions on the interwebs. And so they need the software engineers to tell them this is how it works, this is what it's actually going to replay and pretend to be. And so this brings up the ethical responsibility of programmers. People who write these simulation systems have to communicate the limits and conditions under which the software can be used. So some of the errors that could happen in a simulator, there could be coding errors. And so if you're going to be professional about it, you have to ask yourself, are we building the product correctly? Does it run the simulation correctly? And this actually requires the software designers to take their software, model something, and then actually do the thing that they modeled to see if it's going to work properly. There can also be model errors. it represent what is truly happening. And one of the things that typically is done is it's actually uses math to do that. Even the physics engines in game environments use mathematics to try to model how things are going to behave in a real world setting. And the limits that you guys have all seen, many of you have done game design, you will know that there are limits to how this actually does model the real world. Things like clipping or being able to slip through a wall, things like that can happen when the math isn't actually that accurate. And they also need to ask, have we done all of the significant factors? Finally, how you validate the simulation is critical. And you can't actually model all the things that you're actually go out and physically test everything that your software simulator is going to do. You have to select enough cases that you have a high confidence level that the remaining cases will still work. It's not much different from typical testing methodologies. Unfortunately, there are significant byproducts and outcomes if you don't do that correctly. So, what are your professional responsibilities? We have to avoid harm to others. And if we're going to do any kind of software, especially modeling software, then you have to think about what kind of harm is going to occur with that. And so you have to identify what harm could come. You have to make sure that you're not losing information that can be critical in various different modelings. A lot of them will do in their simulation, they'll do some compression or they'll make some assumptions and use a mathematical formula to compute maybe a next location, but it's ultimately digital, not analog, and so everything is going to jump a little bit depending upon how small your iteration time is. IEEE code goes farther. It says you have to accept responsibility. We talked about this a little bit in class on Tuesday, and we have an ethical obligation to make sure that we are documenting the limits, testing the software, providing accurate knowledge to those who will use it to build things. All right, so now we're going to switch gears. We're going to talk about, is software a product or a service? This is actually a very, very valid discussion. I refer you to the text on this. And I like this three categories that are listed here. There's canned software. That's like you buy a package and you download it and install it. I think of video games or an IDE. You download the IDE, you install it, you use it. It doesn't, now while there are plugins and things like that, the heart of the package is not rebuilt, or you don't go in and write code to modify the heart of the package. Or maybe some of you will someday, but it's not really intended that way. Same thing for like a very small video game or a large accounting software, maybe Paycom's payroll software. You buy the package. Now, that may actually be a service, so let's qualify that. But in a canned service, you're basically getting the whole package and it's delivered to you. You install it as is. You don't modify it. You obviously set parameters and things like that, but you don't modify it. Then there's customized software, and this is where a customer goes to a software development house and says, I have these requirements. I need you to write me some software that will be customized to me, and that is done. And that is a service. That is something that is done for them as a service, whereas canned software, boxed, immutable, unchangeable, is a product. And the difference between these two has an impact on the legal recourse that people have if there are damages from poor programming. Finally, there's a hybrid where the product is mostly canned, but there are some plugins maybe or places where you can customize it. The canned portion would be considered a product, and the customized portion would be considered a service. Why do we care? We care because if a flaw results in damages, the victim, the person who suffered, is entitled legally to gain compensation for their loss. But the compensation type is different. If it's a product, the customer can sue for liability damages. If it's a service, the customer has to sue for malpractice, imperfect or negligent delivery. And these two, make sure you know these two. Canned products have a liability associated with them. Services have malpractice associated with them. In one, you get sued because of a faulty product. In the other, you get sued because of a faulty practice on your part or your company's part. Now, that leads us into the idea of warranties. And warranties, we all are familiar with warranties. You buy piece of technology. You buy a car, it comes with a 1-year warranty. My Honda came with a 12-month warranty, actually a 3-year warranty, bumper to bumper. Everything was covered. That was awesome. But that is a express warranty. It's something that the seller of the product or the manufacturer of the product says to you, I promise that these things are going to work, and here's what I'm going to do if they don't. I'm expressly telling it to you. I'm expressing to you what it is. There are also something called implied warranties. There is a normal expectation that a product is going to work in the way in which it was advertised, in a way in which is expected. And these warranties are implied. They don't have to be written down. They are accepted according to what would be common sense, ha ha, in the courts, right? We don't expect a contract to cover everything. Some things in a product are just expected to be working fine. And so it's possible for an express warranty to exclude some things. For instance, you can say in your express warranty, this product is not warranted for X, Y, and Z. You can actually express that and put a limitation out there saying we're not guaranteeing this component of our product, even though, and you wouldn't say even though, but even though it might typically be concerned with an implied warranty. So here's some typical implied warranties. You have a warranty of merchantability. It means that the product will do what it's supposed to do. That's kind of what I expect. That's kind of what I expressed to you earlier. There's also the warranty of fitness. And this means the product is going to suit the purposes for which it's marketed. It will satisfy the demands of the customer. And there are some things that we can, assume. For instance, if you are purchasing a tool, you can assume that the tool is going to work and it's going to work in a safe manner. All right. So all products have these implied warranties unless they're marked as is. There's a kind of an odd byproduct to this. Whenever you buy a home, you're almost always buying a home as is unless you have it built for you. So here is a situation. This is a real case. Wise sold computer programs to a company called StepSaver, and all the programs had box top license terms that said that opening the package accepted certain terms, including a disclaimer of warranties. Now, StepSaver was going to resell the software to various customers. They started getting sued because of problems with the software, and they sought to get damages from Wise. But Wise argued that every box had the license, and that license voided certain warranties. And the question is, should the box top license be considered as a conditional acceptance when you open it? In other words, can you slap something on the top of a box and say, if you crack the seam on this box, you're agreeing with this? Turned out that the courts had said that the license would not be considered conditional acceptance because the software producer didn't clearly express an unwillingness to proceed unless additional terms were incorporated into their agreement. So in this case, even though it was written on top of the box, the court said, no, you can't force that. Now here's another one that's kind of similar. Timberline, they licensed customized software to a company called Mortenson. The licenses were printed on the boxes and on the envelopes, and Timberline employees even installed the software. So that means the seller or the licensor was the one who was installing it. The program was being used and it exhibited an error that required a reboot. The employees would just restart and continue, but they didn't know that their errors were being incorporated into the bids they were building using this software. As a result, they submitted a bid that was $2 million low. And of course, they won that business, but then hey, wait a minute, we felt like this did not behave in the way that it was expected to. Not only did the express warranty not work, but there are implied warranties about how this thing should have worked. It shouldn't have done this to us. But the customer lost the case. And here's what the court looked at. First, they said the purchase order constituted an integrated contract. So when there was a purchase order given back to Timberline, they said, hey, there's a contract there that you signed. And Mortenson had purchased other software from Timberline, so it was okay to expect that they knew the rules. Second, the license terms were part of the contract. And this is where the court ruled that the installation of the software was an agreement on the part of Mortenson. And third, there were limitations on the remedies clause, and it was too one-sided. And the remedies clause was something that Mortenson had put back on Timberline. And so the contract the contract was not too one-sided to enforce. And so the court said Nope, we're not going to give you anything here. All right. How do you avoid problems with reliability, quality, all the things we've been talking about? These are practices that good programmers, ethical programmers, should build into their process. And most of these have been built into most processes. Any of you who have done any real coding already out in some of your internships will have experienced some of these. There's a formal review process. You write code, you have to submit it to somebody else to look at. And they're responsible for also looking through it. So they have their head on the block along with you if it doesn't, if something bad happens that they didn't catch. There's a code review process, basically what I was just talking about. Oftentimes there are public walkthroughs where the code is discussed as a team and everyone gets a chance to kibitz on it. Of course, we try to have the highest quality testing that we can, and there are plenty of whole classes built on that, semester-long classes built on that. You can probably get a graduate degree in testing methodologies nowadays. And so these definitely need to be built in. And finally, the idea of what is trustworthy. And this is a very short definition, great exam question. What is trustworthy software? It's software that performs as it should, when it should, and how it should. All right, that was a quick blow through, only about 17 minutes long, and just a quick run through to make sure that you are thinking about these things. Again, use the textbook, read it, make sure that you use it to strengthen your understanding of this material.